In this video, we're going to talk about factoring polynomials. So first of all, we're going to do the opposite of factoring, and that's sometimes referred to as foiling. So maybe I'll just write here. So what does FOIL stand for? So if I write it down the side here, so it's the first, the outer, the inner, and the last. Okay, so when you're doing that, the first two terms you want to multiply together, and then you want to do the outer two terms, and then the inner two terms, and then the last two terms. Okay, so sometimes people draw this like a rainbow. So you take these two, and then you take those, the last two, and then you take the inner two, and then you take the last two. Okay, so if we were to do that, we're going to have 2x times x with the first two, and then we have 2x times negative 4 with the outer ones, and then the inner ones we have a 3 times an x, and then the last ones we have a 3 times a negative 4. So if we just simplify that, 2x times x, that's 2x squared. 2x times negative 4 is negative 8x. 3 times x is just 3x. And 3 times negative 4 is negative 12. Now we have some like terms here. Okay, so if I put those like terms together, I get 2x squared. Negative 8x plus 3x is going to be negative 5x, and then minus 12. And we can see that our simplified version matches what it was supposed to. Okay, so that's how you expand factored polynomials. What we want to do is the opposite. So we want to try and go from this side to that side. Okay, so first some terminology. So in the above example, 2x plus 3 and x minus 4 are factors of the polynomial 2x squared minus 5x minus 12. Now note, we could factor 2x plus 3 further, so we could take out, say, the 2, and then what we'd have left over is x plus 3 over 2, so a fraction. We don't normally do that, so here we're going to stick to integer coefficients. Okay, so we normally want the coefficients, so the numbers in front of the x's, to be integers if possible. Okay, so techniques for factoring polynomials. So we could factor out a common monomial. So what is a monomial? Well, it's just a polynomial with one term. Okay, so for example, you could have 2x cubed, or you could have negative 8x, or you could just have a 5. Okay, these are all monomials because they just have one term. So if we look at part A in this example, if we want to factor out a monomial, what we want to do is look for what do these two terms have in common. Okay, so I notice that there's no x's in the second term, so I cannot factor out an x, but there is a common 3. So we could take out the 3, and then we'd have left over from the first term x squared, and then the leftover from the second term is going to be a 2. Okay, so that would be 3 times x squared plus 2. So this little 3 here is our monomial that we factored out. Okay, so sometimes we would call this a common factor because it was common to both terms. Okay, I'm going to leave part B for you to do. So a binomial has two terms. Okay, the bi means 2. So there's some special formulas that we use sometimes. Okay, so there's the difference of squares formula. So that's when you have a square minus another square. Okay, so there's an easy way to factor this. It always factors as, so if it's a squared minus b squared, it's going to be a plus b times a minus b. Let's just see why that might be true. Okay, so if you ever want to check, we could expand. I don't want to use up that space. Okay, sorry about that. Let me just go over here. Okay, so we can expand to check. So we're going to expand the right-hand side. Okay, so it's going to be a times the outer first ones, a times a, plus the outer ones, so a times negative b, plus the inner ones, so that's b times a, and then plus the last ones, which is b times negative b. So if I simplify this, it's a squared minus ab plus ba minus b squared. And we can see it turns out when you expand something of this form that the middle two terms here always cancel each other out. So I'm left with a squared minus b squared. Okay, similarly, there's a formula for sum of cubes. So if you have a cubed plus b cubed, it factors as a plus b times a squared plus, minus ab plus b squared. If you want to check this, expand. Now, when you have you're expanding and one of your factors has three terms, you can't use really the acronym FOIL anymore because there's going to be more terms, but you just take your first one and you multiply it to everything in the other one. And then you take your second one and you do the same thing. Okay, so that's how you expand when there's more terms. There's also a formula for difference of cubes. So it looks very similar to the above one, so you're welcome to use those when you have cubes. Now, what about the sum of squares? Okay, so I have a formula for sum of cubes. Why did I not have a formula for sum of squares here? Okay, now, many people, so there's no formula for this. Okay, these are often, you can't factor these. So what I want to write here, because what's very tempting to do is to write that this is a plus b squared. Okay, so this is not true. Okay, so I'm going to write no again. These are not equal, and to check that, you could expand it out. So if a plus b squared is like a plus b times a plus b. So that's going to be a squared plus ab plus ba plus b squared. So what you simplify to is a squared plus 2ab plus b squared. Okay, so you get this extra middle term. It does not expand the right way. So you cannot factor a squared plus b squared, and I'm hoping that none of you ever do that. There's no formula for the sum of squares, only the sum of cubes. So let's factor a couple of these. I'm just going to do a and c here using these formulas. Okay, so for part A, I have x squared minus 9. So you could think about this as x squared minus 3 squared. And now you can see that it matches the formula a squared minus b squared. So that means I know that this is going to factor as x plus 3 times x minus 3. Okay, because my a is x and my b is 3 in the formula. So this is a difference of squares. Okay, now let's try part C here. So x cubed, okay, so I'm seeing a cube there. Is 8 a cube? It actually is. So 8 is 2 cubed. Okay, so this is going to be a sum of cubes. And in the formula, a is x and b is 2. So I can just plug that in. So this is going to be x plus 2 times x squared minus 2x plus 2 squared, which is 4. Okay, now if you want to check that this is true, we can expand it out. Okay, so if we expand, I'm going to do the x through first. Okay, so x has to go to all of these terms. So that's going to be x squared times x, so x cubed. And then it's going to be minus 2x squared plus 4x. And then I have to put the 2 to everything. So that's plus 2x squared minus 4x plus 8. Okay, now I want to simplify So I'm looking for like terms. That's what I want. So the x cubed, there's no other x cubes. Okay, so x cubed stays. Now I'm looking for x squareds. So I see negative 2x squared and a positive 2x squared. So those actually are going to cancel out. Similarly for x's, I see positive 4x and then a negative 4x. So those are going to cancel out. So I'm just left with x cubed and then plus 8. Okay, so that checks out. Again, I'm going to leave these other two for you to try. Okay, so more complicated factoring. So what if I have a trinomial? So a quadratic that looks like x squared plus bx plus c. So quadratic, if you don't know that word, it's okay. We're going to talk about that later. Just when you have an x squared as your highest power. So when you have something of this form, okay, there's no coefficient in front of the x squared, right? It's a 1. Okay, but you have maybe some coefficient in front of x and some constant term. What we're going to do is we look for two numbers or integers whose product is whatever c is, the constant term, and whose sum is the inner term. Okay, if we have that, I have it written down below. So if we have that, so the product of our two numbers, a and b, is c, and the sum is b, then we can factor it as x plus a times x plus b. Okay, now again, when we get into the next bit, you can see why this is true. So if no such numbers exist, then we say that x squared plus bx plus c is prime. Okay, so what that means is that it cannot be factored with integer coefficients. Okay, not necessarily that it can't be factored at all, but just not with integer coefficients. Okay, so let's try a and c again. So I'm just going to on the side. So I want two numbers, so two integers, okay, that multiply to give me 6 and add to give me 5 here. Okay, so just think about what multiplies to 6. Okay, so 1 and 6, they don't add to 5, they add to 7. Negative 1 and negative 6 would multiply to 6. Okay, they add to negative 7. But 2 and 3 multiply to 6 and they add to 5. Okay, so my numbers are 2 and 3. So that means from above that this factors as x plus 2 times x plus 3. Okay, so that's its factored. And again, if you want to check, all you have to do is expand. So x times x is x squared, plus x times 3 is 3x, plus 2 times x is 2x, plus 2 times 3 is 6. So that's x squared plus 5x plus 6, which is what we wanted. Okay, so that worked out. Okay, let's try one more. So we want to multiply to negative 10 and add to 3. Okay, so what multiplies to 10? So that's going to be 1 and 10, 2 and 5, and that's it actually. Now when we have a negative 10 here, that means one of the terms has to be negative. Okay, so it could be negative 1 and positive 10, or negative 2 and 5, or it could be 1 and negative 10 and 5 and negative, oh sorry, I did that one the same way. 2 and negative 5. Okay, so now we just have to look at all these pairs and see which ones add to 3. Okay, and it turns out that these ones are going to add to positive 3. Right, so negative 2 and 5 adds to 3. So that means that this polynomial factors as x plus negative 2, times x plus 5. Which obviously we might want to write as x minus 2 times x plus 5. Okay, and again, you could check that if you want, but I'm not going to do that here. Okay, grouping. So here, we're actually going to use the technique that we talked about at the beginning, looking for a common factor. So here I have two terms. Okay, they're complicated terms, but there's two terms. And if you notice, both terms have x plus 2 in them. So x plus 2 is a common factor. So I could pull out x plus 2. Okay, now what's left over from the first term? Well, I took out that, so it's just the x squared left. So I have x squared, and now I do the same thing from the second term. X plus 2 I took out, so I just have the plus 9. Okay, so I'm just going to get rid of those brackets now. So we could factor this as x plus 2 times x squared plus 9. Can I factor x squared plus 9 further? This is a sum of cubes. Sum of squares, sorry. Remember, sum of squares does not have a factored form. Okay, so we're done at this point. Okay, let's try another one. Okay, C is more like A, so I'm going to leave that one for you. Let's do part B here. So another way you can do grouping, instead of just looking for common factor, we can group the terms. Okay, so I'm going to look at only these, I'm going to look at these two terms separately and these two terms separately. What do the first set have in common? So x cubed and 2x squared, they both have x squared. So I can factor out an x squared, and then what's left over from here is just one more x. And what's left over from here is just the 2. Okay, now the plus in between, so I leave that. And now I look at the next pair. So what do 9x and 18 have in common? Well, they have a 9 in common. So if I pull out the 9, the first term has an x left over, and the second term has a 2 left over. Okay, so this went to that, and this went to that. Now we can use the same trick we used in part A. So now I see x plus 2 is in both of these two terms. Right? Now I have two big terms. So I can take out x plus 2. And from the first term, I have x squared. And from the second term, I have plus 9. So there's my factored form. So in fact, this polynomial here is the expanded version of that. So notice what we had here is exactly what we had there. Okay, so this is what we call factor by grouping. Okay, I'm going to leave C and D for you to try. Okay, so try those two methods. Now, in our previous one, we had polynomials that looked very similar to this, okay, except there was no A. Okay, the A was 1. So what happens if A is not 1? We can still use a similar method. Okay, so we still look for two numbers whose product now, instead of being C, is going to be, it's going to be A times C. The sum we're looking for is still B though. Okay, so if you get two numbers where A times B is AC and little a plus little b is big B, then we can factor ax squared plus bx plus c. So what we do is we split up this term here. So notice that this is still here, the c is still here, and we just do something in the middle here. So what you can do, so little big B is little a plus little b. So this is actually the same as if I do that, which then you could expand further to be ax plus bx. Okay, so we can basically take this middle term and split it into two terms. Okay, the benefit of doing that is that then we can factor by grouping. Okay, so I'm just going to do 1 here. So let's do part A. Okay, so we want to multiply to 3 times negative 2, so negative 6. And we want to add to 5. Okay, so our numbers are going to be positive 6 and negative 1. Okay, because we're multiplying to a negative number, I need to have one of my numbers negative, and then I want them to add to 5. So 6 is going to be the positive one. Okay, so then I take this polynomial, I leave the first term alone, but I split up the second term. So instead of 5x, I'm going to write it as 6x minus x. And then I still have the minus 2. And then I'm going to factor by grouping. So in the first two, I can take out a 3x. And I'm going to be left with x plus 2. Now I want the second one to look like this. So it doesn't look like they have anything in common, but I can take out a minus 1 from both. So then it's going to be x plus 2. Okay, and now I can factor out the x plus 2. So x plus 2 comes out. From the first term, I have 3x left over. And from the second term, I have the minus 1. So there's my factored form. Okay, now, the last one we're going to talk about is completing the square. This is not people's favorite. And we're going to do it a few times throughout the course. So, what if we didn't have the c? So we just have a polynomial of the form x squared plus bx. We want to turn it into a perfect square. So a perfect square, what that means is it's going to look like x plus a all squared. Okay, that's what we call a perfect square. So to do that, what we need to do is we need to add b over 2 all squared. Okay, how do I know that? Okay, so if it was x plus a all squared, okay, that means that it's x plus a times x plus a. And if you expand this, you get x squared plus 2ax plus a squared. Okay, so what that means is we want b to equal 2a. So that means that a is b over 2 if we solve for a. Okay, and so that means that in order for it to be a perfect square, I need this a squared term. Okay, so that a squared, oops, maybe I don't want to do the arrow that way. That a squared is that term, right? That's my a squared. Okay, so let's just try one of these. So I'm going to do part A here. Okay, so x squared plus 12x. That's what we're starting with. So we want to make it a perfect square. So this thing, this sort of comment up here in the box tells me that I want to add 6 squared. Right? So I have my my x squared plus my 12x. And I want to add 12 over 2 squared. Can I just add a number? No, that changes it. So what I need to do, instead of just adding that number, what I need to do is add the number, but also subtract the number. Okay, so the reason for that is that this is equivalent to plus 0. Plus 0 doesn't do anything. Right? You can always add 0 because it's not doing anything. So if I want to add something, I have to also subtract it. So now I have x squared plus 12x. 12 over 2 is 6, and that squared is 36. Okay, so I have what I started with, and then plus 36 minus 36. And what I'm going to do is just bracket this part. So those are the pieces I want together, because that part is actually x plus 6 all squared. Okay, so I've turned it into a perfect square and then plus a little bit and minus a little bit it turns out to be. Now, let's just check here that it is x plus 6 all squared. So if I have x plus 6 squared, that's x plus 6 times x plus 6. So that's going to be x squared plus 6x plus 6x plus 36. So that's x squared plus 12x plus 36. So that bit is that bit. Okay, so it was the perfect square. Okay, now I'm going to leave part B for you to try. So that's a brief introduction into, or maybe not introduction, but recollection into how we factor polynomials.